All right, everyone, welcome back. For today's lecture, we're going to continue on the three-part construction of our Arkanoid project that we started last lecture. So as a quick review, take a look at... Is it cool if I turn it like that? Yeah, go for it, please. Thank you. So last lecture, we went into just generally setting up our... All the way down, yep. And then the tube behind you, on your right. Yep. So we looked at just general functionality with our project in terms of like what we wanted to get done, what our final product would end up looking like. We took a look at the resource we were going to use as our kind of game design template, where we were going from. I pulled the image from Wikipedia that we looked at, the Arkanoid project, from the old days. I pulled information about it, like its width and height, and then I determined I wanted to scale that up a little bit to make it proper for a modern, higher resolution environment. Went through and showed you how we could customize a number of the settings, both for the player settings so that it would look proper in our game view, but also we looked at a little bit of code to further reinforce that once you actually built the game. So we also looked at just organizing our project in general, the different folders, the stuff that would eventually go into each one, just to keep some form of, some semblance of order as we continued through. And then we started actually building out the individual pieces. So we built the game manager, the paddle, the ball, and brick. We didn't do really anything with the brick. We got the paddle moving back and forth. We got the ball bouncing around our scene, launching by pressing a button on the paddle. So in today's lecture, we're going to go through and take a number of the systems that we just had the shell of. So in this case, like Game Manager currently only has a wake in it. It only does something with the resolution. So we're going to expand upon that to make it a bit more powerful, a bit more of the central brains of our program, or at least the primary location where all communication tends to happen. We'll go through, and some of the stuff that we created just as placeholders for starting up, making sure we didn't hit the fire button twice, making sure that we were actually playing versus not to prevent some things from processing. We'll go through and we'll do what's referred to as refactoring. We'll refactor some of that code to basically move it. Instead of having a single Boolean existing inside a couple of different scripts that could each have their own state, we'll take those two variables, we'll make a version of it inside our game manager, and then we'll link that single variable into our other two files. And then you'll see how, depending on where you call it and where you use it, you always have a one centralized location for all your data. Now, generally speaking, we're going to go through and take the ball and lock it to the paddle. We're going to give it that little offset that we were talking about. We're also going to fiddle around more with the ball's physics. We're going to actually do the collision response and the reflection off of different walls and that kind of stuff. Like I said, we're going to update the game manager, so it's going to be using a very specific data pattern, a very specific design pattern. If abused, it can be very controversial out there. But generally speaking, the way this project works is I only want a single instance of this manager, which is what a singleton pattern does. I also want just a few variables to be stored somewhere. And in this case, because I'm not going to do like a separate database or some kind of secondary data class or whatever, this particular project, it's perfectly reasonable to say it'll also contain my variables. And then I'll just communicate with it both for setting and retrieving those values elsewhere. We'll also look at the general scoring concepts, like how do I determine whether or not I've lost this game versus won this game. This will take into consideration a death plane at the bottom of our screen, and this will also take into consideration the individual blocks as we count them up and then destroy them and decrement that counter. The bricks themselves are actually going to be special. When we get to that code, you'll notice the the bricks are self-aware to a certain extent. They handle their own counting in terms of construction and destruction. And so you'll notice how we can then in other systems ask, hey, brick, how many bricks are there in the scene? And this will start to play into the idea, like as we've worked on some other things up to this point, you've seen me call out to things that, like for example, debug.log, right? I'm not accessing a special version of the debug class, right? An instance of it. I'm calling directly from the class debug. Other variable types like transform, we put a this, and that's optional depending on how you're using it. We want to talk to the class that we're this particular copy of the class, and it's possible to have multiples of these things out there in your scene, which is why we use keywords like this to differentiate like which object we're actually talking to. This is also very demonstrable when you take a look at the capital G game object versus the lowercase g game object. The capital G version is the whole class itself. That's like debug, right? It's the whole thing. It's calling back up to like its template. When you create a game object and you want to talk to this ball versus this brick versus this other brick versus this paddle, which game object are you talking about? Well, when you start working inside that script, the lowercase g game object represents that instance out there in your scene. So we'll take a look at some of that as well as it relates to the bricks as well as to the game manager itself. Okay, that wraps up the slides because pretty much all the rest of the stuff is in code. So just as a quick review of what we did last time, the stuff in right now we're dealing with just the one scene. We've named it level 1. We've got a number of our systems all set up, our play area, that kind of stuff. We've gone through and constructed a number of items being used in our scene or on different game objects and whatnot. And so when we play, it basically looks like this. I can use the A and D key to move my paddle around. I can use the left and right arrow to also move it around. I can press spacebar and it will fire the ball. In that case, it fired it right into this brick right here in the dead center. That's the only one. If I pick my Arkanoid layout and turn it off, you can see that that's the only object. So it just happened to slam into that. Now if I stop playing and play again, you see that time it bounced, it flung and just missed the paddle, so it didn't lose all of its physics. But as soon as it hit the top, the ceiling, it also lost its physics. So that's basically where we sit. Now we continue on. All right, so I'm going to jump back into code, and let's start talking about mapping the ball directly to the paddle. That way we can move it around and determine where we want to actually start from. So taking a look at the paddle, okay, I need to go through and actually do some kind of math to figure out where things are positioned in my scene and where I can like link these things to. So right after the ball, because this is related to the ball, it's not related to this is playing stuff, which, by the way, when we get to the game manager, this is part of the stuff that's going to be changed, refactored. So right after ball, I'm going to say I need a vector 3. I'm going to call it V as in Victor, ball offset. Okay, this is going to store the difference, the delta between the paddle and the ball so that we can actually place it where we need to when we start. Now, here inside start, right after we retrieve the ball, we want to get some information not only about the paddle but also the ball itself. This is part of the scaling thing I was talking about regarding the renderers giving me proper scaling information. So I need to talk to both the renderer that's currently on my paddle as well as the renderer that's on my ball, do some math with the stuff that's inside it to calculate my offset. So I'm going to fill in the BV ball offset But in this case, I specifically want to deal with the y, because the x component of this thing is going to be mapped every single time when it starts, it's going to be locked to where the ball or where the paddle is, and then as I move my paddle left and right, it's going to follow along the x-axis. The y offset is always there. We just need to calculate that one time. So the value that I need is half of the paddle's y, right, from the center of the paddle up to the top of it, and then the radius of the ball. Those two numbers combined. So I need to get the component, specifically the renderer, off of this this paddle. Okay, I want to know what its bounds are. And then from there, I can talk to the extents, and that's just giving me the general shell of the object. And I want to know its vertical offset from center, which is the y value. Now I want to add that to the same information but coming from the ball. So being efficient here, I know that I'm going to use the exact same line of code, so I can just copy this from get component all the way down to this y, Control C. And on the next line, I'm going to use that same code, but I want to talk to the ball. So b dot, and now if I paste, I get that exact same math coming back over and semicolon to end that line. So those two bits of information will give us our offset just in general. Okay. So now I need to actually map that ball to the paddle, but then also use that vertical offset. So if I come down here to update, where I'm monitoring for key presses and monitoring for the launch call, you'll notice B is playing, but then I have that exclamation mark at the beginning saying if I'm not playing. Well, if I'm not playing, then I want to put the ball right to the paddle. If I am playing, then launch will take over and I'll allow the ball to control its own physics, and we'll be fine from there. So a good place to store this, or rather a good place to apply this update is while we're not playing, but before we've actually started playing. So inside the body of the if, but just before we deal with the key code or the key code space, we need to go through and say that the ball, so B, its transform dot position is equal to the paddle's position, so that's off of the transform, plus the offset. Okay. So now all I'm doing is repositioning things based on, put the ball where the paddle is and include the offset. Okay, so if I save and jump back over to Unity, Unity, here we go. Real quick, I want to get rid of this error because that's going to become annoying. And you've seen me do this a handful of times. I just close the file, open it back up from Unity, and then save it with the re-encoded lines. So at the moment, we can ignore the let me just verify this. Okay, this is just a general warning about the fact that the first one is that random range has actually been shortened to range, so I'll fix that probably in the next version of this project. But this is a heads up. If you ever see this kind of stuff that is either obsolete or deprecated or something, that's a heads up that this version of Unity is probably going to, or future versions of Unity will probably lose that specific method call. So it's suggesting what you should use. So update your code, and then if you ever jump to a later version of Unity, you won't get the error or the warning. It's just a way of them polishing their software behind the scenes. This. I guess I wasn't using it. Okay. Anyway, so So now I verified everything with the paddle in terms of code. So if I jump back to Unity and I hit play, you'll notice the ball starting up here will snap to where the paddle is. And now if I left right arrow or A, D, you'll notice the ball maintains its location attached directly to the center but vertically offset. So now I can hit space and it fires directly from that location. Cool. So that gets us a little bit more control over what's going on in the scene. So now I want to refactor the way that variable we were just looking at, the be start playing, or is playing, or start, or that kind of stuff. I want to refactor that so that our game manager is actually what's responsible for coordinating, for orchestrating interactions between those multiple objects, those scripts. So if I jump back to my code and I want to do a couple of things. One, just so I don't accidentally leave these variables in my code, I'm going to come through and I'm just going to comment it out. I could delete it, but I'm going to use this as a visual placeholder for myself to know that it's gone. This is what would need to be updated. And now if I scroll down through, you'll notice Visual Studio has already started detecting that because I removed the variable, the usage points in my code where that variable was being used are now in error. That's fine. I'm going to use that to my advantage. Now, the brick doesn't have anything. The ball, same thing. Line number 8, just going to comment that out. So that will cause any other use points to also fail. Okay, so jumping back over to the game manager. Now, the game manager, the way it's going to be used, it's going to be a little different than most other objects you've seen so far. I'm going to turn it into a prefab at some point, but I'm actually going to apply it to like the very first, when we get to it, the very first start screen. Now, when I go from the start screen into level 1, I currently also have a game manager sitting in my level 1. Well, because I want to orchestrate starting the game, scoring information, that kind of stuff, I only want to store that in one location. I don't want 2 or more to potentially overlap or get out of sync or whatever. So I'm going to turn the game manager into what's called a singleton, meaning it will only ever exist one time. There's a lot more tech involved in this, but what I'm going to show you is like the basic bits that we need just to get this thing functional. A real project, if it was even using this kind of tech, would go in and do more stuff regarding like when the scenes were shutting down and more proper stuff, especially involving like threads and locking and that kind of stuff. But for this project, it's incredibly straightforward, simple. I don't need all those extra bells and whistles and safeguards. So to turn this game manager into a singleton, I need to come through and make a couple of updates. Number one, I need to make this game manager the one and only game manager out there in existence. So I need to make it static. So up here at the top of the game manager class, I'm going to apply public, because I'm going to be accessing this class from elsewhere. Static, meaning it's going to stick around. And then the type is game manager. It's the same class. And I'm going to call this instance. And to start it out, I want to actually set this to null, so it doesn't have any other information. And I can check this. This is a known value. Null is a known value that I can then start doing some verification against. So down here inside awake, I actually want to give myself a little bit of space before I do the resolution stuff. Because again, I only want to do the resolution stuff just the one time, right? And the way a singleton works is it gets created one time. Any others, any duplicates that it detects, like if I go from start, which would have one, into level 1, which would have one, the version in level 1 is detected and destroyed immediately. The one that I created in start, the very first one that was ever detected, that's the one and only game manager that I want across my entire project. So inside awake, I need to come through, and that instance variable I created just a second ago, I need to say if instance is currently equal to null, then I need to remember myself, right? I'm the one being created, so instance equals this. And that's the this class reference. That's talking to this game object, this component rather. Okay. Now, alternatively, if I'm in some other scene or I create another instance of this game manager and I call it, awake will also be called when the object gets created. So I need to additionally say else if instance. Now, in this case, it could be some other version of this game manager, which means that this will differ from the instance this that we just captured a second ago. So if it does not equal this, I need to immediately destroy myself. And the version of myself, I'm talking to this whole object, not just this. I want to say lowercase g game object, which should nuke the entire thing. Now, this code would continue to roll along. Unity, the engine, would go off and eventually destroy this game object. But like I said, I've got extra code down here at the bottom for set resolution that I only want to happen the one time. The one single instance up there at the top, instance equals this, that's the one that I want to do this kind of work. So if this object is being destroyed in a nanosecond, I don't want it to do any extra work. So just return immediately. That'll bypass any extra logic on the next few lines. Now the thing is, when you transition from, let's say, start to level 1 or to level 2 or anything like that, the act of loading a scene, unless it's additive, will actually purge the contents of the current scene you're dealing with. This is just a default feature of Unity. So you start with a clean environment for every scene you're working in. In this case, I want my game manager to persist from level 1 to level 2 and so on, start to level 1, so on. So I need to somehow inform the engine to not destroy this game object. The call to do that is don't destroy on load. And I need to tell it which object, this game object. Okay? So this alone will turn this object into a singleton. It will allow me to only have one instance of it at any given point. Now, the thing is, I said I want to refactor some of that playing code. The is playing, be is playing, that kind of stuff. So to do that, I'm going to keep my variables in a cluster up here at the top, like all together. So I'm going to make a little note to myself and say this is data. And the variable that I want to use to track all this stuff, I don't want it exposed to the outside world, so I'm going to leave it private. But I want to say your called is playing, or sorry, you're called playing. Okay? Now, to do interaction with the outside world, you saw it before. I could create properties to just, or I could create methods to set or get or whatever, pass parameters around. But I could also just write a property, and that's what I'll do in this case because it's a little bit less code. So just above all of my normal methods, I'm going to do a public property. It's going to be dealing with a bool, and I'm just going to call it playing. I need to be able to ask if I'm playing, so I need a getter, and this will do a return of be playing. Then I also need to set it, right? Whenever I press the space bar, I need to say, hey, I'm playing, so game manager, say you're playing. So to be able to set that, I need a setter, and I need to set be playing equal to the incoming value, whatever that happens to be. Okay? Okay, and I'll leave this space here because I'm going to add some more variables shortly, so it doesn't necessarily matter if there's extra space there. Okay, so now that I've got access to the outside world to query the current state of this game manager singleton, I need to actually use that code. So the first thing I did was I broke Actually, let me take a step back. So even though I purposely broke both the ball and the paddle to use this new functionality, I can now use Unity to tell me where I've broken it. Right? I could go hunting through here. I could look at there should be an error list. There's a window that tells me errors that Visual Studio detects. But I could also just jump back over to Unity, let it try to compile, and now it's going to spit out a number of issues. Okay? I made sure that my stuff was saved. And now, okay, it's going to complain about ball's line endings. Okay, so let me go to ball, close ball, jump back, open it. Okay, I've changed the line endings. I've saved. I'll jump back over to Unity, let it compile again. It's complaining about Game Manager. Okay, let's double click on Game Manager, close it, jump back to Unity, open it back up, change the line endings, save. Jump back to Unity, let it compile. So this is just bouncing back and forth. I'm relying on the two programs to understand what kind of manipulation in terms of like the line endings on one side versus trying to compile it and looking for issues. I'm going to ignore this this warning for the moment. I'm going to now look at ball and paddle where it started running into issues. So when it comes to the let's go to the ball. Okay, and this is inside our launch code. So if I jump down to the ball, let's see here, launch code. Come on, mouse, get over there. All right. So now, instead of using isPlaying, which is that variable that's local to this script, I want to replace that with a call to my game manager. So to do that, just going to start this on one line and I'll erase the next one. I need to talk to, just like we did with debug.log and vector3.whatever, right? I need to talk to the game manager dot, and now if I start scrolling through this list, you'll notice I have some things available to me. These destroy object, immediate, that kind of stuff. These are all part of the mono behaviors parent hierarchy. If you go looking through this thing, you'll find elsewhere in Unity's engine, inside its code, that's where these things exist. So if you're curious, just to show you what I'm talking about, right here at the very top, mono behavior, if I right-click on that and go to definition, clicking that will take me to the parent. Now I can look through and I can see I have all these things. I can do the same thing for behavior. Right? Go to definition. Now I start seeing some other stuff. Well, what about component? You can continue up this chain. There's game object, the one we're currently talking to. We have the rigid body, that kind of stuff. So some of this stuff, here's get component. So it's up there. You're just not seeing it written in our file, right? It exists up in the parent. So that's how you would get to it should you want to just do a little bit more research into that. So scrolling back down to ball's launch. Now I'm talking to the game manager, so the variable I specifically want to talk to, because everything else, looking through this list, there's nothing else from the game manager that's exposed. Everything else is all private. The stuff you're seeing in this list comes from its parent, from its inheritance. In this case, I want to talk to the instance. And for reference, that's this variable right here. Okay? And I want to ask it for a variable. In this case, when I go looking through this list, I should have playing right here. And I can see that this is game manager playing. It's a property. That's the one I want to deal with. So when I launch, I want to set playing to true. So at this point, I just need to say, you're true. And I can delete that next line because I'm no longer using it. Okay. Now, save. And let's see here. I'm going to go ahead and get rid of this is playing at the top just so it doesn't clutter up my workspace a little bit. Okay. Save. Jump back to Unity. Let it do its compile. Cool. Now we're going to deal with the paddle. So double click that, jump back to paddle. All right, same thing. So I want to get rid of this is playing up here at the top and jump it back down to the error line itself. I want to replace this with a call directly to my game manager and ask it if it is not playing. So just before the variable itself, I can leave that exclamation mark in there, and I can say game manager dot instance dot playing, and then I can just get rid of the Boolean that I was talking to a second ago. This will, because I'm querying it, it will invoke the getter, returning me whether or not I am or am not playing, and I'll invert that using this exclamation mark. Same thing that happened over in the ball, right, when I started tracking the stuff, was to modify this is playing here. So I need the game manager dot instance playing, so I can just go ahead and copy that and paste it. Okay? So these lines tell me whether or not I am or am not playing, and these lines tell me that I am now playing, right? I've toggled the system so it actually starts to respond. Okay? So now go through and just do one verification pass. Jump back to Unity, let it compile. Should get rid of all my errors once it compiles. And now at this point, you'll notice something a little different about my hierarchy when I start playing. I get this don't destroy on load scene, right? The little Unity icon here represents scene, just like up here at the top. And if I hit the disclosure triangle, you'll notice the game manager is now listed as a thing not to destroy. That's because of that method called onGameObject earlier that says stick around. So now over here in my scene, if I just press spacebar, everything should function exactly like it did a second ago. Okay? So that's just refactoring the code, moving it around, so now I'm dealing with one single instance controlling variable information and state as opposed to multiple scripts. Okay? So now that I've got the ball talking, the paddle talking, and the game manager itself talking, now I can fix up the physics that the ball actually would use to bounce around my scene properly. So to do that, I'm going to jump over to the ball. Okay? And there are a few things to just generally keep in mind with this. As I fire the ball and it bounces around the scene, I want to know when the ball collides with anything. That way I can do a reflection. Okay? The thing is, you would run into this if you actually wrote this code and started experimenting with what's going on. Now, when I launch the ball, I say go some random direction and a unit vector, right? So it's 1 unit length, and then fire at with a power of 10. So I know that that velocity as that ball kicks around my scene should be some very specific constant speed. Now, when the ball slams into one of the walls, right now you're seeing the thing goes to a dead stop. It doesn't bounce off. Well, if you inspect the rigid body of the ball, if you inspect its velocity inside on collision inner, you'll see that it's actually a much different value than what you originally told it to fire around the scene as. That math is basically the aftermath, right? You've impacted something, maybe you're still scooting along the top or whatever, but the math, just generally speaking, is different. So we need to go through and kind of remember what happened just prior to impact. So we're going to reverse time just a little bit. Now, if you refer back to that execution order link to Unity that I gave you early on, you'll notice that when we're talking about physics, we do fixed update first, then we start responding to the collision. So I'm going to use that to my advantage. For starters, the velocity vector is a vec3, so I want to retain that variable, that value somewhere. So up here at the top of ball, right here in my variables section, I want to go ahead and say vector3. I'm going to call this v, just as a prefix for vector, velocity, if I can spell, velocity last frame. And the idea is update's going to be ticking along, then we'll run into collision. Well, what happened just a second ago? The last frame. Update ticks in frames, fixed update ticks in frames. So having a location for it is fine, but now I actually need to use it. So I said in last lecture I'm going to repurpose update over here. Let's see here. I don't need this comment referring to update because fixed update could call multiple times per frame or not. It's just however you've decided to set the physics engine. These things are customizable. So I want to get rid of that comment because it's no longer relevant, but I want to change update to be fixed update. Okay? And now if I'm bouncing the ball around the scene, I want to do the logic. If I'm not bouncing the ball around the scene, I don't want the ball to try messing with physics in any way. I don't want to have to deal with any of that stuff. So I can just ask my game manager, if I'm not playing, then don't do any of the work. If I am playing, then go ahead and do normal physics as I expect. So inside fixed update, I can do if not game manager dot instance dot playing. If I'm not playing, just return. If I am playing, however, I want to store whatever that previous velocity was before it gets stomped on when it slams into something, and then on collision enter gets called. So the vector that I created a second ago, v velocity last frame, is equal to the rigid body's velocity. Okay, just a simple storage before it gets blasted by slamming into something. Okay, so now that I've got that information, I can actually make use of it. So if I scroll down just past launch, just past apply velocity, I need to actually respond to when the ball slams into something. Now I'm doing this in the ball as opposed to in other objects, and you'll notice, just generally speaking, I'm going to pick and choose certain locations in some of these objects for handling certain things. Like collision responses, I'm going to allow the ball to do it. I'm going to allow, in any case, what considerations I'm keeping in the back of my mind as I design this is, if you look at the original design document for Arkanoid, you have power-ups that can create multiple balls flying around out there in your scene. You can do all these different things, multiple bricks, multiple brick types. So it can matter where your logic exists. The whole point is, like, you don't want to necessarily rewrite whole sections of code. So when it comes to collision handling and that kind of stuff, centralize it into one thing, the thing that's usually going to deal with it. But then if you have multiples, just keep in the back of your mind that it is just those multiple instances. So they're all they're self-reliant. They don't depend on any other systems to do what's going on. So the paddle, per the original design, is actually your ship, right? You're controlling it, and you deal with the balls flying around in the scene. So if you're curious why I'm deciding to put collision controlling information here versus like the paddle versus other locations, that's one of the design considerations that I had to sort out as I constructed this. Okay, so to start handling physics just in general, I need to call out to on collision enter. This is a method just like start, update, awake, etc. that's built into Unity's engine, and I no longer need the private here at the beginning, so I can get rid of that. Okay. It just makes the code cleaner, right? It's private by default. So when I actually do start playing the game, I have yet to figure it out whether or not it's a bug in Unity, but every so often what will happen is your ball, where it's physically located in the scene, could potentially overlap with certain other objects in the scene, certain other colliders, triggers, that kind of stuff. So we want to basically say any of this extra code that is responding to slamming into walls, ending the game if we hit the bottom death plane, We don't want to deal with that if we're not playing. Okay, so during startup, when the game is like actually creating and positioning objects, there's the possibility something could overlap and immediately in the game. Well, I don't want that. So just like talking to the game manager before, here when we're dealing with on collision enter, I want to also say if I'm not actually playing yet, don't do any kind of collision response stuff. Specifically, I put that ball really close to that paddle. As I move the paddle around, the ball is basically nudged right up against it, and you'll get collision messages sent back to the system because it doesn't know that you're not doing it. Now, I could obviously go into the code and put a little tiny offset to the offset, right, and physically move the two apart, but that would require me to know that that's a thing. And then if I scaled it, right, that offset might not be correct anymore. So instead of dealing with all that, I'm just going to say, if I'm not playing, don't respond to collision systems. So inside on collision enter, very first thing I want to do is say if I'm not game manager instance playing. If I'm not playing, just like we did a second ago in fixed update, just return. But I do want to tell myself if this is a scenario, like I want to be notified, like, hey, this is what I'm actively avoiding. So I'm just going to, for informational purposes, I'm going to throw in a debug.log warning, which will give me a little bit more of a visual indicator that something's a little amiss as opposed to my normal logs. And I just want to say ball, because that's the class I'm calling this from, and I'm going to shorten this method's name to OCE instead of on collision enter. Real estate's kind of important sometimes. So ball on collision enter was detected, but I'm not playing. So a very quick little heads up to myself that something happened that probably shouldn't have been, but I've avoided it because of this return. Okay? So at this point, the ball would have slammed into something. I know I have its previous velocity just prior to slamming into that thing. So now I need to reflect the actual vector. Now the vector information is correct. Its magnitude is wrong. So in this case, if I scroll back up for just a second, when I did the launch code, right, I was calculating a new vector based on some random information into this vdir, the direction. So I need to recalculate the direction and then fling it out there into my scene based on the reflection. Now notice this apply velocity is doing some extra stuff that I would normally have to do just generally dealing with vectors. First thing, I need to get the direction as a normalized unit vector because any additional magnitude that creeps along would then be multiplied by this power value, which would then potentially artificially either accelerate or decelerate my ball as it bounced around the scene. So I know going into this that regardless of whatever vdir was, it's going to be squished down to a unit circle, or in this case, I guess a unit circle, not sphere, and then have its power levels restored based on what we set. Just a few lines. Let's see here. Launch doesn't have it. So at the very top of the file, where I have power set to 10. Okay, so that's the launch power that the thing's going to have, and then I just restore that into the velocity. Physics would come along a second later and go, cool, I see that I have an active velocity going in the other direction of a magnitude of 10. Launch this sucker, or relaunch this sucker. So when I start dealing with on collision enter, I need to do a few things. One, I want to recalculate that direction vector based on the reflection of the thing that I just slammed into. So vector3 dot reflect takes in two different bits of information. One is the incoming vector, and that was the v velocity last frame and what we slammed into. Now the collision engine is going to give me information about the surface that I just hit. Specifically, I need to reflect it based off the normal. So the perpendicular ray coming off of that surface. So in this case, up here at the top, I get for free this collision. Collision is the class. Lowercase c collision is the instance. This will contain a bunch of information about what the physics engine just just saw. So I can talk to, jump down a line, I can talk to that collision variable dot contacts. This is the potential impact locations. I want to talk to the very first one, because if I mouse over this, you'll see it's an array, right? Contact point array. And then I want to talk to the normal of the very first thing that I slammed into. That will satisfy the reflex requirements. Okay, now that I've taken the information just prior to impact and I've given myself a proper direction, I can call this renormalization, repower application code, which is just calling apply velocity. So right after I recalculate direction, I can call apply velocity. Okay, so that, if I save, okay, anybody need any second to copy that over? We good? Cool. So if I jump back over to Unity and I play after it finishes compiling, at this point, if I press spacebar, you'll notice the ball is now bouncing around my scene. And I can turn off this layout so that we can get a better view of it. Okay? And you'll also notice over here in my scene, remember I had a debug ray inside apply velocity. That way I could see what it was actually calculating as it impacted things. So now I can see that every one of these impact vectors does retain A, the direction, B, the magnitude. It is properly reflecting off the different surfaces. Now, it might be difficult to demonstrate here, but there is a scenario where, let's see here if I can, okay, see how the ball, see those rays out there in my scene, how they're now different compared to the original big sets of multiple prints. The thing that's going on behind the scenes as this thing is bouncing around is it's taking the surface normal and reflecting that. Well, these cubes, right, when you start dealing with the ball reflecting off of the edges, those normals can actually be angular. They're not full vertical or horizontal. They can be angled around the edge, which will cause deviations in the flight path of the ball. What can end up happening is between that consideration and the fact that it's possibly going to, I mean, it's going to be bouncing off a whole bunch of other bricks as you build out these levels. I mean, just take a look at that, right? As the ball enters one, bounces off, reflects, and destroys, maybe it bounces up into the next one, and kind of tunnels up through this, destroying blocks as it runs along. Well, what can end up happening is, notice how close to no y velocity it's currently got. If it impacts in just the right way, it will lock onto the x-axis or the y-axis. Now, if it's the x-axis, you basically just put your paddle in the way and it would prevent you from losing. But at that point, you basically can never really score anymore unless you happen to get just the right angle so that it hits your paddle and flies back into the scene. If it goes horizontal, right, it doesn't have a y component anymore, you're done. You have to stop playing because it will never recover. So what I want to do is actually detect for that kind of scenario. And this is kind of a cheat, it's kind of a hack, but it will prevent some erroneous physics from entering my game. Now the idea is, if I can be monitoring the velocities, the vector velocities x and y, and I detect that it drops below a certain threshold, usually it drops to 0, but the numbers get so small we start possibly dealing with machine epsilon. Now, that's a really tiny number as well, and at that point, I don't really want to deal with that code looking at if I'm dealing with a really tiny number. I wanted to give myself a bigger boost. So I'm going to artificially say if my velocity in either of those two components drops below a certain threshold, then either in the positive or negative, doesn't matter, then just go ahead and recalculate, give it a slight little nudge, nudge if necessary, and then it should never enter that state where I'm basically forced to quit playing. So to do that, let's see here. I wasn't paying attention, so where did it go? Oh. Case endpoint. If you leave it running long enough, you'll see it. That's the issue I'm talking about. At this point, if I was playing this game, I would have to stop playing because there's no recovery from that. Notice the X transform is actually updating, but the Y is locked in at 4.9. Well, what I basically need to do is give it just the slightest adjustment to break that velocity problem. Right? If I was to look at the rigid body's velocity dot y, it would be 0. So I need to just kind of nudge that ever so slightly. Okay? So if I jump back to my code, and let's see here. I said I want to get a nudge factor, right? If the velocity drops below this particular threshold, positive or negative, I want to just add this value back into it to kind of just give it just the slightest little push back into our play space. So to do that, I need a value. So I'm going to go float f nudge factor. And I'm going to set it equal to 0.1f. It's a pretty small value, but it'll get the job done for what's actually happening. Now, to apply this, I need to actually create a method that's going to do checking of the velocity and then update accordingly. So if I scroll down past all my Unity stuff, past, let's see here, past launch, past apply vector, I just put it in.
What was it, 0.01 did you say?
0.1.
Nudge factor 0.1?
Yeah. 0.1, yep. Okay, so just after apply velocity, but before on collision enter, I want to create myself another utility method, very similar to apply vector, but in this case I'm going to apply, velocity. I'm going to apply a slight modification. In this case, I said I need to nudge this thing if necessary, so that'll work. Nudge if necessary. I don't need it to be called from anywhere else other than this ball, so I don't need it public. Now what I need to do is determine whether or not my velocity in either the X or Y has dropped below a certain threshold. Now if it's really small in the positive, really small in the negative, doesn't matter. It's just really small and I need to adjust it. So what I need to do is get the absolute value of X. If it's negative, it'll be positive. If it's positive, it'll stay positive. So I need to go through and say, if the absolute value has dropped below my nudge value, then go ahead and apply a specific nudge in this particular axis. I don't want to necessarily fiddle with Y if it's only a problem with X and vice versa. So I need to say what that modification is going to be to each component, to each X or Y. So if I say fx nudge, right? This will be the nudge value for my X. I want to default that to 0. And I also want another nudge factor for my Y and set that to 0. Okay? This will, just like the direction modifier over in paddle, every time we come through this method, it'll just make sure that these guys are defaulted to 0. I think I can leave these off, right, the actual settings, but it's just visually it's an indication to me like, yeah, I'm actively setting it to 0, and sometimes the compiler will say, hey, you're trying to use a variable that hasn't been modified. Actually, that's the other part of this. I'll show you in just a second. So now that I've got something to adjust, now I need to do some actual checking. So if mathf absolute, if the absolute value of my rigid body's velocity.x, if that's dropped below my nudge threshold, right? The nudge factor, I'm going to reuse the variable here. I need to come through and say the fx nudge value is going to be some alteration. Now, I don't want it to always go up, because if the ball, like you saw a second ago, the ball bouncing back and forth at the top of the scene, if I said always go positive, it would continue to climb and continue to rest itself against the top of this play area. So I want to randomly pick whether or not it can go up or down. And this will allow me to, with that one single burst of direction, allow me to continue, bouncing around the scene, and hopefully we can get our paddle in the way, or it can bounce into something else. And the second it collides with something, that will then trigger the collision, direction change, and power levels and that kind of stuff. So any kind of deflection that happens will be immediately erased as soon as it touches something else. So to do that, I need to call out to random. In this case, I'll use the correct version, so just random range. And the values I want to randomly range between is a negative nudge factor and a positive nudge factor. Okay? Now I need to do this exact same thing, but for y. So if, and notice I'm not using else if here, because either of the two could be independently changed. So, or they could both happen at the same time, which would be kind of weird. But let's ignore that for a second. So I need to do mathf.absolute, get the rigid body's velocity.y, and see if it has dropped below the nudge factor. If it did, the y nudge is now going to be a random range between negative f nudge factor and positive f nudge factor. Okay? Now that I've determined whether or not I do need to nudge this thing in some direction, I can actually do the nudge. So rigid body's velocity, add just the slightest bit of vector modification. So I need a new vector 3, and I'm going to pass in fx nudge and fy nudge. Okay? Yeah, no problem. I noted earlier that if I got rid of those defaults, right, that it would probably complain. That's what that red line is. Unassigned local variables actively being used. Even though the system sets it to 0, it's saying, hey, as a heads up, you probably should do this. And in this case, because it's an error, I have to do that in order to compile and continue on. And again, I'm taking advantage of the fact that the vector3's constructor has multiple versions. So I'm omitting the z component here because it's going to default to 0 anyway. Okay, all caught up?
Yeah.
Okay, yeah.
You sort of why my
my only question is, how do you rename stuff that you made in the assets folder? Because there's no, like, if you right click, there's no, like, rename thing.
You're on Windows, correct?
Yeah.
Okay. If you jump over to any of the stuff down here, you do this through Unity. Don't do this through Explorer. Unity tracks a lot of the stuff behind the scenes in a secret database in the library folder. And if you start renaming things, it should detect, but sometimes it can get confused and link in improper ways. It's rare, but it can happen. So best bet, do this stuff in Unity. It monitors it. It'll correct everything itself. So what you do one of two things. If you have the object already selected, click on it again, and you'll go into rename mode. The other way is with the object selected, press F2 on your keyboard to go into rename mode. And then just change it to whatever. And because it's tracking stuff, it should automatically update that throughout the rest of its settings. If I drag and dropped items, if I rename scripts, right? If I rename ball to ball 2, down here at the bottom, this would say ball 2 because it knows this thing behind the scenes. They're not based on name, basically. Okay? So now that I've got the code to actually do nudging of the ball in case it gets into a weird state, I actually need to do that operation. I need to call nudge if necessary. So if I scroll back up to fixed update, when I do start playing, but before we've made any kind of modification, because at this point, the rigid body velocity is compromised, so I need to possibly nudge it so that our last frame's information was correct. So just between these two, give myself a little space, and just call nudge if necessary. Okay, so every frame that fixed update ticks, it's going to monitor just in case that happens to be an issue. Okay, where is... There we are. Okay, everybody good? All right, jumping back over to Unity real quick. I should compile. There shouldn't be any kind of issues. And while I'm at it, just go ahead and remove this range word from this random. That way, that error that warning goes away. Random dot range. Naming matters sometimes. So, jump back to Unity. This should go away. Yes. Okay, cool. So now if I start playing, I'm not going to sit here while it continues to bounce around because at this point that should have solved that problem. So I'd be probably waiting for for the sun to burn out or whatever. So, but as you can see right here, ball on collision enter was detected, but it was not. We weren't actually playing, and so that happens right there at the start. Now, if I move, sometimes it can kind of shake around. Again, this is all under the control of the physics engine, so sometimes the ball is a little wobbly on top of the paddle. So sometimes I can get a second printout, third printout, that kind of deal, just by kind of bouncing around. In any case, so that gets us the ability to get out of that scenario where we get locked into. Okay, so let's see. Now let's take a look at actually hitting something, right? We need some target in our scene to interact with. Well, the brick at the moment doesn't do a whole lot of anything. Its script has really nothing in it. So let's go take a look at it. Okay, so for this, let's see here. We're going to look at as we scatter these bricks around through our scene, right? It would be nice if they could count themselves up, right? We don't have to have some kind of a manager doing counting, because we could duplicate these bricks as long as it has the script on it. The script is basically responsible for counting these things up. So you saw over there in my game manager, I used a static variable called instance to track just the one single instance of the game manager. Well, wouldn't it be nice if the brick as a concept was capable of counting all the little bricks that were out there in my scene? Well, I'm going to use basically the exact same concept. I'm going to use a static counter to basically say whenever start is called, meaning this script has been applied to something, it will consider that as a brick. When I destroy the object, right, I hit it with the ball and it gets destroyed, I will decrement that count. The idea is when I end the level, I should be back to a sum total of 0 bricks. The actual destruction code and point scoring and that kind of stuff will come just in a little bit. But let's actually take a look at making this brick stick around. Okay, so inside the brick class at the very top, I need to create a public, I want to see it to the outside world, static, and I could reverse either of these two words. So if it pops up like in a test, these two words kind of link together. It just means that it's going to be visible to the outside world and static. It's an integer because I'm only counting whole bricks. And I'm going to call it s underscore because it's a static. And I probably should apply the s over there in my game manager. But because I'm using instance all over the place, naming convention-wise, it's kind of a whoops. So in count is what I'm going to call it. And I want to default that to be 0. When we start up, we're going to have 0 of these things in our scene. Now, when I actually have this script come alive on some game object out there, I want to count that number up. So I can say s in count plus plus. The thing is, though, I only want to track bricks that are capable of being destroyed. So if the object was created out there in my scene and it's intended to be destroyed, I know that it should have a collider, a box collider, sphere collider, whatever, right? It's going to have a collider on it. So I can do a little bit more error checking and make this brick a little bit more aware of its environment and that kind of stuff. So, and this will also give me, as a designer, a heads up that maybe I've applied this script to something accidentally, like a parent node if I have a whole bunch of bricks in a row. And that way I can see, hey, I'm not able to leave because I've not destroyed all the bricks because that empty node that represents a parent, a folder kind of deal, doesn't actually have the ability to be destroyed. So I need to gain access to the collider. And in this case, it's not a box collider, not a sphere collider, none of that stuff. It's just the parent collider object. I'm going to call it col. Now, when I start, I want to just reach out and ask, do I have a collider on this object? So col equals get component collider. That'll return me any kind of collider. And I want to say, if I do indeed have a collider, then and only then can I start counting up these objects. Okay? If I didn't, if I somehow screwed up, put this on an object that it shouldn't have been a part of, I need to give myself some kind of a warning. So I'm going to put an else and debug log warning. In this case, I'm calling it from the brick class. I'm calling from the start method. And I just want to say that the collider was not found. You should fix this. Because this will absolutely impact gameplay in weird ways if you can't leave the level. Okay? Now, for this particular project, I don't need the bricks to be doing anything per frame. All the collision, all the destruction, all that stuff, that's going to be triggered by other systems. So I actually do not need update at all. So I can just go ahead and get rid of it. Or I can leave it, doesn't matter. I do, however, know that when the ball strikes the brick, it's going to destroy it. So I need to handle that. I need to write some systems to handle both the impact as well as the cleanup of that brick itself. So to start out with, I'm going to go ahead and say let's handle the cleanup, right? That's going to decrement the counter. So elsewhere, when I go to destroy, just like in the game manager, when I say destroy this brick, it'll call a method called onDestroy. This is a unity built in, just like several of the other ones we've seen so far. I don't need private. And now, basically, it's going to be the exact same concept, the exact same logic here inside start, except we're going to decrement, and we're going to say we're having an issue from a different location. So I can just copy everything that I've got inside start at the moment, come down here to destroy, and paste. And now I need to make a couple of adjustments. One, if we're destroying it, we are deleting the brick, so the counter needs to go down. If we're calling destroy on something that for whatever reason doesn't have a collider, we need to come along and say, hey, this thing still needs a collider in order to get this this count updated properly. So in this case, brick start actually needs to become brick on destroy. And the same message applies. Collider's not found. We can update that accordingly. Okay? So that'll take care of our construction and destruction of the object. Now we need to have the ability, as the ball's bouncing around the scene, colliding with things. Right now we're dealing with walls, right? We don't do anything with the paddle or bricks at the moment. But at some point, we want to be able to detect that the thing we've collided with is actually a brick. And if it is, we need to tell the brick to self-destruct, right? That's what's going to handle all the logic. Again, going back to that where do things live, in this case, I'll tell the brick that it's been impacted, and it can do whatever magic it wants. Launch power-ups, start spinning off the screen, go invulnerable, whatever. It's totally up to you as designers to figure that kind of gameplay mechanic out. So I'm going to need to call this method from elsewhere, so it's going to be public. I don't need to return anything, and I'm going to call this hit taken. Now, the thing about a brick that you can hit is, well, do I hit it once and destroy it? Do I hit it 2 times, 3 times, 10 times, 100 times, whatever? I'd like that to be variable. I'd like to be able to tune that. Maybe one brick is immediately destroyed, but the next brick over takes 2 hits or 3 hits. And maybe I have the ability to kind of modify the scoring. Maybe an impact, if I've managed to somehow hit it, that's worth 1 point. If I destroy it, maybe that's 5 points, something along those lines. So I have complete control over this stuff. So as I'm dealing with hit in general, those are the things that I kind of want to approach. So up here at the top, where I've created my count and my collision, I want to create a few more customizable variables to both deal with the impacts, the hits, and the scoring. So I want to expose these so that I can tune them in the inspector, but I do not want to expose these to outside scripts. I don't want the potential for somebody else to accidentally say, hey, that brick is actually worth 15 points as opposed to whatever. You could. It's totally possible. But when you start exposing variables in isolated things to other bits of code, you start creating spaghetti code. You start mixing it together. You start creating dependencies on other systems that shouldn't be there. So you could have a method, right, that maybe updates some kind of score, maybe takes in a parameter to change. But in this case, I just want to, for simplicity's sake, for this prototype, I want to expose it through the inspector. So to do that, I need a serialized field. And I'm going to call this, actually it needs to be an integer because these are, let's go with the points and then we'll go with the hits themselves. So how much is this thing worth? Well, it's going to be an integer value. And I'm going to say in for integer, points on collision. I'm going to default that to 1. I want another serialized field. And I'm going to call this in points on destroy. I'm going to also set that to 1. Now I need to know about impact information. So I want to be able to tune this brick if I can hit it once, twice, 10 times, whatever. So that is also a serialized field. It's also an integer. And this one, I'm going to say max hits. Currently, I want it to default to 1. Now, every time the ball hits it, I actually need to count up. Did I just get hit once? Did I get hit 2 times, 3 times, 100 times, whatever? I need to count that. So in hits taken, I don't want to default that to anything other than 0, and I don't want to expose that in any way. So I'm going to leave off the serialized field. Now, just in case, as kind of a sanity check, I want to make sure that if this brick comes alive, we reset the hits taken back to 0. Okay. And then when we get into level management, how we actually transition from scene to scene, we'll start looking at ways of detecting whether or not this was the final brick destroyed versus when you, like if you lose and you go on to like the lose level, the act of transitioning scenes also destroys the bricks. So we'll use a quick check to see if I destroyed it or if the scene's destruction destroyed it. We'll get to that in most likely the next lecture, maybe. Reset? This guy here? Yeah. All set?
Yeah.
Okay. So back down here inside hit taken, this will reflect a single hit, right? The ball could bounce off it a zillion times. I'm only concerned with the one single impact. So I need to count up the hits taken. Then I want to see if I've exceeded or met that threshold to actually do the destruction of this particular object. So if the N hits taken exceeds, right, greater than or equal to the N max hits, I can just call out to destroy game object, just like we did with the game manager. If it was another instance, destroy it. If I got hit enough times, destroy it. This particular brick. Okay? So that gives this brick the ability to both count up and get destroyed. Let's see here. Now I need to actually inform it that it has been hit. So if I go back over to the paddle, that's where all my collision detection is actually happening. Or, sorry, no, the ball. If I go back to the ball, and down at the bottom where I'm doing on collision enter, right? If I'm playing, everything's cool, I'm reflecting, I'm getting a new velocity. At this point, I want to say if the thing that I just slammed into was a brick, go ahead and inform that brick that it was just hit. So I can create a quick brick to call out to, right? Because what I'm going to do is, if I just slammed into a game object out there in my scene, excuse me, I'm going to look through its hierarchy, through its inspector. I'm going to look through its component list. If I find that I have a brick script attached to it, then I can talk directly to that script that I just wrote. So using B here, I'm actually going to use a slightly different technique than what you've seen up to now. You've seen inside if checks where we can do double equals for comparison, right? And as well as several other kinds of checks. You've seen where we do assignments using a single equals. But as I said during the if lecture, that all that matters inside that ifs parentheses is whether or not that logic resolves to be true or false. You know, null or not null. So if I happen to have some logic that assigns a variable, and that variable does indeed exist when the if check actually checks, then that's perfectly fine. So in this case, I want to do a quick combination of those two bits of tech and say B is going to be equals one single equal sign to collision. That's the parameter up here at the top, right? This is the physics engine telling me I just hit something. I want to ask it its game object, which would be the entire thing, if it happens to have a component named brick. If get component on this game object succeeds, B will be filled with some information, meaning it will not be null, which means if it's got something, this if check will succeed. If it's still null because of the failure, it will not execute the next lines of code. So inside the body, I can just directly call b.hitTaken, that method that I just created in the other file. Okay. Anyone need a little extra time on that one? You guys good? All right. So if I jump back over to Unity, and for this one, it's complaining about brick. So let me jump over to brick real quick. Close it. Reopen it. Do the conversion. Save. Jump back. Let it compile. Okay. So these two errors, or rather these two warnings, specifically on the private fields points, both of the 2 points things, we're not actively using them just yet, so that's why it's complaining about that. But we'll resolve that shortly. Okay. So at this point, I can play, and before I launch my ball into my scene, I just want to turn off this Arkanoid layout so that we see that it's this one single brick out there. Click back into my scene to give it into my game view to give it focus again, and fire. Now, at some point, that ball should impact. Now notice here, the ball slammed into the left wall, lost all of its lateral velocity, but because our nudge factor stepped in, it's now allowing us to continue playing the game. So as the ball continues to bounce, it's eventually... There's another example of it. It slammed into the the left side of the paddle, which neutralized its lateral force, and the random pick that it just happened to deal with was going to the left. So it's going to run into the left wall again. So I'm going to move the paddle out of the way. This time it won't suffer from that issue. But there's the correction code actively doing its job. So in this case, when it finishes bouncing around and actually hits the brick, boom. The brick, notice over here in my hierarchy, has been destroyed. And that's basically it. We haven't done any kind of reporting or anything. We just take into consideration it's now gone. So if I stop playing, there's the brick. And if you were to duplicate this, right, and move it around a little bit, you get the same scenario. If I turn off the Arkanoid visual, let this thing bounce around my scene, boom and boom. So now that I've verified that that all seems to be working, now I can go through and actually build in logic to consider wins or consider loses. So to do that, let's see here. This is actually a little, give me 1 second. Okay. So this logic is actually spread across the game manager because that's where we're going to control how we can actually do these things, and the brick once we've destroyed it. But then we also have the scenario where if the ball were to leave the play area, right? At this moment, all 4 walls currently reflect our ball around the scene. But I don't want the floor to do that. In the final version of this game, I want, if you miss the ball with your paddle, you could either lose a life, you could lose the level completely and then be sent to some other level, like an ending screen. We'll get into that in the next lecture. But I need to be able to see that kind of thing happen. So the very first thing I want to do is give myself the ability, let's see here. I want to give myself the ability to actually lose. So to do that, if I take a step back, actually I want to delete this brick. I don't need it anymore, this second one. Okay, save my scene, jump back to code. Now, the game manager is going to be responsible for the concept of winning and losing. So I'm going to write lose. So if I jump back over to my game manager, I want to, let's see here, come down to the bottom. This is going to be after awake, right? I'm going to be writing a number of functions over the rest of this lecture and next lecture to kind of stitch all this stuff together. This is our central point of communication between all of our different things. So in this case, this is actually part of the ending conditions. Yeah, data, ending conditions. Okay, so I want to be able to call this particular method from elsewhere. Specifically, when the ball leaves the play area, I'm going to respond to collision, but in a slightly different way. And I need to inform the game manager that I have indeed lost. So it's going to be public void lose. And for the moment, let's just go ahead and say debug.log I lost. We'll refactor this code to actually do something more in next lecture. So now that I have the ability to lose, let me save this script, jump back over to the ball, and now down at the very bottom we've done collision, right? The four walls currently collide, the brick collides, the paddle collides. We're currently only responding to the brick to actually do something, but any other collision reflects us in some direction. That's general across the board. The thing is, the floor needs to be a kind of collider that I can't actually bounce off of, which in this case is not a collider per se, it's a trigger. So much like if you were to walk up to like a supermarket and you hit that rubber mat right in front, there's a sensor that detects you're walking into the store. That detection then says open up the collider, which is the door. So those two things play in conjunction to allow you entry into the store. So Unity has similar things built into it, similar kinds of physics stuff. So I have another collision response call out there called onTrigger enter. And I don't need the private in the beginning. But you'll notice the parameter differs. This one's called other. This one up here was called collision. The class was collision, because we were doing collision. Collision is not the same thing when you're dealing with triggers, so they swapped out the name to collider. They are kind of functionally the same, but they do have differences. And if you screw up the names here in your code, either it will be seen as a custom method that you've written, or it will be seen as a method signature that doesn't match what the engine has. And that will give you an error. So if you ever notice that your colliders or your trigger stuff just isn't functioning, double check. Double check what you've written. Make sure that it's, capital C, the words, these different things. Make sure it's blue, syntax highlighting. IntelliSense is going to update you on some of this stuff. So useful little hints coming back from the system. Now, my goal here is that if I let the ball slide down to the bottom, to the floor, I don't want it to reflect, but I do still want to be notified. So the first thing is I can't do any of this unless I'm actually playing the game. I don't want it to accidentally prematurely end my game. So I want to say if I'm not game manager instance playing, and just like we did with the collision, I want to give myself a warning that something happened and it probably shouldn't have. So debug.log warning. The ball on trigger enter, but not playing. And then return. This will prevent it from doing any kind of erroneous activities. Now, I'm going to take a break here for a split second and jump over to Unity. And notice here inside my hierarchy, under the play area, I named my floor. Now, also notice over here in my inspector, the box collider component, I have this entry called isTrigger. Now, it's currently set to false, meaning it's going to be a collider. So I want to check that. And because I don't have any scripts controlling this, I can't, I mean, I could write a script and have it change this inside the code, inside like start, but in this case, I just want to use the inspector. Okay, so now it's currently a trigger, meaning that if I start playing, right, we turn off this Arcanoid layout. If I start playing, when that ball reflects around this scene and comes back down to the bottom, yoink, it's gone. It left the play area. Now I would have been notified in my code that a trigger response happened. So now that that's set, I'm going to save my scene so that I retain that toggle, or rather that toggle. Jump back to my code, and now I can actually respond to this scenario. Now I just said that the floor was actually named floor. So the other parameter coming in, other, I can ask it for its name, and I can say if that is equal to floor, and here I have to match that string exactly. There are other versions of this. You can use tags and whatnot. I'm just going with this so I don't have to mess with some other systems. And at this point, I want to tell the game manager that I have lost. So game manager.instance.lose. Okay. So now if I play this in Unity, it should, once the ball leaves the play area, blink, I lost. This is calling from game manager. The ball is calling the game manager and telling me that I lost. Okay, so we now know that that functionality is actually proper. So the other aspect is actually winning. Well, we've already established that whenever the last brick in the scene has been destroyed, you have no other purpose there, right? Your job is done. You've won. So we can go in and actually count that up. Take a look at the number of bricks, make sure that we've actually destroyed them. And so to do that, let's see here. The game manager, it won't necessarily call win directly, okay? The game manager's win will actually be called by an internal call, because I don't want any other systems out there to be like, I just won the game as a cheat or something like that. So the idea is, if I jump back to my code, jump over to the game manager, calling win is going to be governed by some kind of status that I get back from some kind of other check. And in this case, I want to check to make sure that I've killed off all of my bricks. So I need to be able to, when a brick is destroyed, it might be the very last brick. It might be the very first in 100 bricks in that scene. I want to ask it, every single time it's destroyed, is this the last brick? And if it is, was it because I killed it? Again, if we transition scenes, all the content in your scene gets destroyed anyway. So I don't want onDestroy called by the engine saying that I actually won. Because what will end up happening is if you accidentally do that, if you say just transition to win if the last one has been destroyed, as you leave the level, let's say you lost. As you leave the level, that scene gets destroyed. All the bricks in it get destroyed. The code says, hey, congratulations, you just won because you destroyed all the bricks. Go to the win screen. So what you were doing, going to lose, is overridden, and you get bypassed and sent to a completely different location. And it's simply because of the nature of how things get destroyed. So we need to verify that we were the ones actually doing the destruction and then trigger a win based on that. So to do that kind of counting, I want to say that when the brick was destroyed, I'm going to call a method to just check on the count. So it needs to be public. It's not going to return anything. And this is going to be called last brick destroyed check. Last brick destroyed check. Okay, give myself a little space. And I do know that this is what's going to call when. So I can go ahead and prototype, or I can flesh in, whatever, put in the when method. All right, I'll flesh that out in just a second. But what I want to do is ask the brick class if its static counter has indeed dropped to 0. Now, remember that over here in the brick, okay, on destroy gets called when we call destroy. We basically flag Unity, the engine, to say at some point in the next frame or so, destroy this object. Now, when we hit the object, that will then tell the engine to come along and eventually destroy itself. And then once we look at this object, we've destroyed it, then we can actually start checking that count because we will have decremented here inside on destroy. So the game manager needs to ask if brick.sn count is less than or equal to 0. Go ahead and call when. Now when, for the moment, is just going to say I won. Okay. Now the brick itself needs to make that call. Needs to call this public last brick destroyed check. So I'm going to save the game manager so that I can see that method over here inside brick. And so inside on destroy, right? Let's say this was the first brick destroyed. Cool, I've decremented the counter. Let's say this was the last brick destroyed. Now we have no remaining things because this 1 would have gone to 0, the decrement. After that, I can then do a check to say if I've actually done the hits to destroy this thing, so if n hits taken is greater than or equal to the n maximum hits, this is where I can call out to the game manager's instance and tell it to check on the last brick destroyed. Was this indeed the last brick? And if you'll notice, scrolling back down here to hits taken, that's the same code in terms of the check to see whether or not we've actually triggered the destroy. Here, if you transition scenes, this count will mismatch, meaning it won't do the check for bricks and whatnot. Okay? Yeah. Mm-hmm. All right, so jumping back over to Unity, and at this point, we're not actively counting the points just yet. They still exist, but that's what that last warning is, last pair of warnings. So we can kind of ignore that for the moment. Go ahead and play, and I want to turn off my Arkanoid so I can actually see what's going on. Now, if I start playing this, and whoops, well, I can't play anymore. I've lost, but that ball is cruising off into infinity. Now, in the version that we're going to finish up in next lecture, you'll actually go to a lose screen. You won't care what's going on with that ball. If you include something like lives, you would instead of just losing the ball, you would say like decrement lives, and if your lives have decremented below a specific threshold, then you actually lose. But you would also want to reset the ball. So in that case, you would actually go through and like toggle the game manager, and then you could reset some of those, like the ball's position. As soon as you stop playing on the game manager, it should revert back to not playing state, meaning the ball should immediately snap back to where it was before we started playing. Because remember, that's the alternative playing, right? That's the alternate play style, right? We're either mapping the ball to the paddle or we're letting the ball fly around the scene, one or the other. So in this case, that was fine, but for testing purposes, I actually want to turn off that lose functionality because now I'm specifically trying to target this brick, and I don't necessarily want to, make my block or my paddle really large or fiddle around with it in any other way. So I can just go over here to my floor and turn off the trigger. Now this will revert the code back over to the collision response, and now the brick will turn off this Arcanoid layout. Now, as the ball flies around the scene, it will bounce off the floor, okay? And when it hits the last brick in the scene, it will say, I won. Now, you can verify this by going to, just go ahead and turn that off. Go ahead and grab the brick, duplicate it, move it back over, whatever, and now start playing. And as long as I keep my paddle out of the way, notice I'm still playing. I've not been told that I've won yet. Boom. Now I won. Now if I accidentally come through, I deleted that second brick that I just created. Now if I accidentally come through and say create myself just an arbitrary game object out there in my scene, and I accidentally apply the brick script to it, I will get all the brick functionality, but I won't be able to respond to any collision because it's not a thing. It won't be able to be destroyed. So if I start playing, brick start, collider was not found, you should fix this. Because here's the problem. If I start playing, and that one real brick goes away. Oh, okay, so my code was too good for itself. This error, right, if you remember, this warning rather, remember if I find a collider, then I increment the count. If you don't do this kind of thing, you may intend for something to be a brick, but it's not actually going to count as a brick. Using this kind of code prevents us from getting into a scenario where that random game object considered itself a brick. So at this point, if I were to comment out this line and try to run it again, then you wouldn't actually leave right? Whoops, that was wrong. So if I just, whoop. So if I just commented that out, and then had my secondary game object over here and tried to play, and because that can also be kind of a pain to try to track what's going on there, if I pause, I know it's going down and to the right. If I grab the ball, slide this back over, artificially change physics, and now play, notice I no longer get the I won message because it still thinks that there's a brick out there in my scene. Because as soon as this game object started, it got counted. So as long as you keep this kind of check in place, then you shouldn't run into any kind of issues with making sure that your objects are indeed the type that you expect and the quantity that you expect. Okay, I think I'm going to wrap up for tonight's lecture. There's a number of other things that we'll go into in next. We'll construct the UI. We'll start constructing the scenes themselves, just duplicating. We'll start the actual process of going from level to level. We'll start looking at how you can plug buttons into you can plug the game manager into buttons to gain access to functionality. Like right now, our did I just destroy the last brick, go to win? Or did I lose, go to, just print out one of those two messages. In the final version of this, what you'll be able to do is say, go to a specific scene, or load up the next scene. And so we'll be doing some level tracking that will allow us to look at our next location in terms of the build settings, right? Those scenes in the let's see here. Inside Unity, if I do Control-Shift-B, this dialog, we'll be adding our scenes to this. And when you do, you'll get both a name. This is the full location, but the name is level 01 with the underscore. And then its index is 0. We'll be going through taking a look at how we can manipulate the scene management system to allow us to go to the next level in the chain or jump to a specific level. So we'll be able to then say, level 1, level 2, and if you successfully complete that chain, then you go to win. Right? Level 1, level 2, win. If you fail, you would go to lose or end or whatever. And so we'll take a look at how that works out. Yeah. I believe that will conclude. Let me verify my notes here. Yes, that will conclude everything for this lecture. So any questions, comments, concerns from here in the class or in the chat? I'm gonna see here. No? All right, I'm gonna go ahead and stop the recording.